back to the reaction stuff here, guys. So with reaction stuff, okay, we have our 5 types, okay? We know we've got synthesis reactions. Okay, we know we've got decomposition reactions. Okay, we've got combustion. Single and double replacement. Okay, we've got our 5 basic types here. All right, what we're going to be moving on to, okay, is starting to look at how do I predict what the products of this reaction are going to be. Okay, the first step in being able to predict the products of a reaction is to be able to figure out what kind of reaction is going on with only the reactants. Okay, so if we look at our 5 reaction types, they all have a unique starting point. Okay, for a synthesis reaction, okay, we have like an element plus another element. And it goes like that. That's the only reaction type that starts that way. Okay, for a decomposition reaction, it's the only reaction type that has only one reactant. Okay? The only thing it can do is break down because there's nothing for it to react with. Okay? For a combustion reaction, we know we're always starting with, okay, carbon, okay, and hydrogen. Sorry, I'm putting an N and then 2N plus 2. Like, I don't know if you guys noticed this pattern, but like if I have C6, I have H14. It's 2 times N plus 2 more. It's that way for every alkane type of organic material. Okay, not something you need to know. We're just kind of putting it in there. Okay, you know, I'll just write it this way. It's probably easier to make sense of it this way. Let's just do this. C6 H14 plus O2. Okay, we got a carbon, hydrogen containing compounds reacting with oxygen. Okay, in a single replacement reaction, we always start with an element and an ionic compound. And in a double replacement reaction, we always start with 2 ionic compounds. Okay? Each one looks different. Without even having the products, each one looks different. Okay? Your task is going to be able to identify a reaction if that's all I give you. Okay, just the reactants. Okay, now from there, once you identify the type, this is where you need to know the pattern. If you recall earlier this week, I said, guys, the one thing you're going to study this week, it needs to be the 5 reaction types and their patterns, because the patterns allow us to figure out what's going to happen. Okay, in a synthesis reaction, these 2 elements react. What do they form? One compound. That's the pattern for a synthesis reaction. As long as I know that, it's easy for me to go, oh yeah, that's what I'm going to get with that reaction. Those 2 things are going to go together. And then, of course, I would balance it, right? I'd put, you know, a 2 here and a 2 there, and 1 there, and it would be balanced. As long as I know the pattern, it isn't hard for me to figure out who goes with who. All right? In a decomposition reaction, what's this thing going to do? It's going to split. Okay? What's it made of? Nitrogen and hydrogen. What do I need to remember about both of those?
Special.
They're both special. Okay, so I just go 2 and 2, and then I would balance, right? So 3 and 2, okay, and a 1. It's not really any different than what you've been doing already. You've always been asked to identify the reaction type. Now you just need to know the pattern well enough to put it together. Okay? Combustion reactions are easy. What are always the product no matter what the fuel is?
Carbon dioxide and water.
Carbon dioxide and water. Okay? That's just one you just memorize. You don't even have to do any figuring with that one. You're always going to get those two things in a combustion reaction. Always. Okay? If I'm balancing this one, do I need both rules? Okay. So I needed 12. That would be 28. So 24 plus 14 is 38, so 19. Okay? You've done all this stuff already. Okay? Only thing I'm asking you to do now is basically know what Dalton said in his fourth point. Atoms can be separated, joined, or rearranged. You know you can't create anything new here, right? It's not like on the product side of this reaction, I've got to go, oh, I'll get gold and silver on the other side, right? I don't have to guess. I know what's going to be over there. I just have to use the pattern to figure out how it goes together. Okay? So in this one, I've got magnesium as an element reacting with this ionic compound. The pattern for single replacement is the element replaces what it's like. Okay, so magnesium is a metal, so it's going to replace the metal. So that means who ends up alone? Lead. Okay, so now lead's by itself. I've got magnesium chloride, that's an ionic compound, so I would have to drop and swap. Okay, remember, I'm not creating anything new, I just have to figure out who goes with who. Double replacement reactions are also pretty easy. Okay, all that goes on in a double replacement reaction is the metals switch. Because we know replacement reactions can only make what kind of compounds? Ionic. The only way I get two different ionic compounds is by switching the metals. The metals can't end up together. Okay? That wouldn't make an ionic compound. All right, so I would have and then I would have to balance it. I'd have to balance that reaction too. I didn't. Okay, that's where we're headed. We might try a few of those near, kind of the midway to the end of the period today. Okay, what I'm wanting you guys to make sure you look over is know the patterns. Once you know the patterns, this part's really quite simple. Okay, you know what's going to be in the products. You can't create anything new, and you just have to figure out who goes with who. All right. Okay. I want you to write those three down. That's what we finished off doing yesterday. Okay, was I gave you the word formula, you have to write the formula form of it for me. Okay, so I want formula form, type, and balance. These three, please. Okay, so in our first one we have iodine. What do I have to remember about iodine? Yeah, it comes as a 2. It's part of the 7 and the 7 there. Okay, and it reacts with magnesium. Okay, which is not special, to form magnesium iodide. So Mg, okay, that's a 2 plus, I 1 minus, so we're looking at Mg I2. Okay, is that already balanced? 1 magnesium, 2 iodines on both sides? I think so. Okay, what kind of reaction is that? It's a synthesis reaction. Okay. How many people have done number 2? Okay. So in number 2, I got copper 2 nitrate. So ionic compound. Charge on copper is 2, because that's what the Roman numeral is telling me. Okay, it's with nitrate, NO3. That's a 1 minus, so I'm going to need brackets with a 2 outside of them. Okay, and it's reacting with sodium. Okay, and that's going to produce sodium nitrate. That's a +1. Nitrate's a -1, so that works out that way. And copper. Okay, what kind of reaction is that? single replacement. I got an ionic compound and an element. Okay, balancing wise, 2 is my biggest number right here. So a 2 there balances the nitrates, but gives me 2 sodiums. I had to come back here and put a 2 in front of the sodium, and then everything else should be good. Okay. How many people have done the third one? Okay, let's go over the third one too then. Okay, so we got silver nitrate, so that's Ag, and that's a +1. It's with nitrate, NO3. That's a 1-, so that compound's fine the way I wrote it. Reacts with lead 2 phosphide. Okay, so Pb with the 2+ charge with phosphorus, which is a -3, so that'll be Pb3P2. Okay, and that is going to produce silver phosphide, so Ag +1 with phosphorus -3. Okay, so that'll be Ag3P. Okay, and lead 2 nitrates. Alright, so Pb, that's the 2+, nitrate's a 1-, brackets with a 2 outside, okay, takes care of that. Alright, on that one, do you have to be on the ball? Alright, if you forget to drop and swap, okay, from here it's going to go badly. Okay, gotta always remember to drop and swap all your ionic compounds. Okay, what kind of reaction is that? Double replacement, all ionic compounds. Okay, biggest number is 3. It's on both lead and silver, but lead has a bigger charge. Lead's a +2. So let's start with lead. Okay, so I got 3 leads here, but I only have 1 here. So what needs to go here? 3. Okay, now when I put that 3 there, how many nitrates does that give me? 6. All right, so I'm going to go back over here and make sure that I have 6 nitrates. But when I do that, I get 6 silver. So what needs to go in front of this? A 2. And I'm pretty sure that putting that 2 there fixes my phosphorus problem. And now everything is balanced. Okay. Ringing a bell from yesterday? Okay, we got 2 more. Okay, let's try number 4 here, guys. So I got disulfur trinitride. So how many S's? Okay, and how many N's? Okay, and it says it breaks down. All right, what kind of reaction is that then? That's a decomposition reaction, right? Into sulfur and nitrogen. What do I have to remember about those two? They're both special. One of them is the most special of all the special elements. Which one? Sulfur. It comes as an 8. Okay, and this one comes as a 2. Okay, so now we've got that. Okay, we said it's a decomposition reaction already. What should I balance first? I'd say the 8. Yeah, biggest number is our general rule, right? There's 8 sulfur over there. What needs to go here to make 8? 4. Okay, 4 times 2 is 8. 4 times 3 is 12. What do I need here to get 12? Okay, then we're good. All right, anybody need more time on 5? Okay. So for number 5, we got our combustion reaction here because we got our C9H20. Okay, so we'll just write right away that that's combustion. Okay, so C9H20 plus oxygen gives CO2 and water. All right, do I need both rules? I do not. 9 is an odd number, so I don't need the rule of 2 here. Okay, alphabetical order, starting with carbon. 9 carbons there, 9 carbons there. Okay, that's supposed to be a 20, not an O. 20 hydrogens. Okay, 20 hydrogens. And now I can do the oxygens. 9 times 2 is 18, plus 10 more is 28. 14 there, and it should be balanced. Okay? How are we feeling about those? Okay? Going from word to formula is the same skill set, okay, as going the other way. But you just have to be looking for all the little details. Okay? The special elements, the drops and swaps, okay, that kind of thing. The balancing is the same either way. All right, I'm going to give you guys about a, let's say, 4-minute break here within the classroom. Get up, walk around, okay, and then we're going to have a look at a couple of predicting ones. Let's look at doing a couple of prediction ones here. I want you guys to write these 2 down, okay, and I want you to see if you can predict what the products of those 2 reactions would be and balance the reaction. Okay, the balancing part's same as what you've been doing, right? Your first step to predicting is to identify the type. You can refer to your notes if you want, okay, and look at the pattern for that type to help you. Okay, but I'd like you to try those 2, give you a few minutes, and then we'll walk through them together. Okay, are we good to look at 1 and 2? Okay. So in reaction number 1, I've got an element reacting with an element. What kind of reaction starts that way? Synthesis reaction. Okay. In a synthesis reaction, what are those 2 elements going to do? They're going to combine. Okay. So if I combine magnesium and iodine, I get what kind of compound? I get an ionic compound. That means I got to drop and swap. Okay. We may have looked at this one earlier today already. Okay. Did I just predict the products of that reaction?
Yeah.
Didn't have to think too hard about it either, did I? Right? It's a synthesis reaction. I know they're going to go together. I put them together. I drop and swap. And just so happens on this one, the reaction's already balanced. Okay? What kind of reaction is the second one? It's a single replacement reaction. I have an element reacting with an ionic compound. Now, here's the thing I have to remember about the pattern for a single replacement reaction. The element has to replace the part of the ionic compound that it is similar to. Chlorine is a non-metal, so that means it's going to swap out fluorine. So who ends up alone? Fluorine ends up alone. Okay, and sodium ends up with chlorine. Okay, now when I do that, is this a special element? Okay, always got to check for that. It's F2. What kind of compound is this? It's ionic. Okay, I got to double check my drops and swaps. Okay, it's fine the way I wrote it. Now what do I have to do? Balance. Yeah, okay, nothing we haven't done before, right? Okay, there's 2 chlorines here. Now there's 2 chlorines over here. That gives me 2 sodiums. Put a 2 there. That gives me 2 fluorines. I think I'm good. Okay. Do you see how you need to refer back to the pattern a little bit there? And it's totally okay to go back in your notes and find that pattern until you know them well enough that you don't have to go back to your notes. Okay? All right. Try those 3. Okay, so on number 3, I've got hydrogen, carbon containing compounds reacting with oxygen. What kind of reaction? Combustion reaction. Okay, what are always the products of a combustion reaction? CO2 and water. Okay, do I need both rules for this one? I do. 2's an even number. All right, so I'll start with a 2. Okay, and then I'll go alphabetical. 2 times 2 carbons is 4 carbons. 2 times 6 hydrogens is 12. 6 times 2 is 12. Okay, and then here, 4 times 2 oxygens is 8. Okay, plus 6 more is 14. 7 times 2 is 14. Okay, how are we doing on number 4? Anybody want more time on 4? In number 4, I only have 1 reactant. I have only 1 reaction type that starts that way. What is it? Decomposition. Okay. In a decomposition, the pattern is the elements are going to split apart. So I'm going to have sulfur, and I'm going to have 8, apparently, oxygen. Got ahead of myself. What number should go on the sulfur? 8. Okay. And what number should go on the oxygen? 2. Okay, little things to watch, right? Decomposition reactions and single replacement reactions can often produce special elements, so you always got to be checking them. Okay, all right, now I need to balance this. Should I start with 8? Biggest number. Okay, what do I need to multiply this one by? 4. Okay, and then for the oxygens, 4 times 3 is? Okay, what needs to go here? 6. You got it. Okay. How many people have done 5? Okay, I'll give you a couple more minutes on 5, okay, and we'll see how we do. You can. All right. So on number 5, I've got sodium oxide reacting with beryllium phosphide. They're both what kind of compounds? They're both ionic, okay? What's the only kind of reaction that starts with 2 ionic? Double replacement. Okay, the pattern for a double replacement reaction is I do what with the metals? Just swap them, right? So what sodium was with oxygen here, so on the other side, that means beryllium will be with oxygen. Okay, and that means that sodium will be with phosphorus. Now, this question often comes up. Coder, does it matter which one of these compounds I write first? Absolutely not. Okay, as long as they're both there, it doesn't matter which one you write first. Okay. Now, what have I not done to both of these ionic compounds? I didn't drop and swap either one. Yeah, so I better do that. All right, beryllium's a +2, oxygen's a -2, so that compound's okay. Okay, sodium is a +1, phosphorus is a -3, so Na3P. Okay, biggest number is 3. It's on both beryllium and sodium, but beryllium's got a bigger charge, so let's start with that. Okay, I got 3 berylliums. How many here? Just 1, so what goes here? Now, when I do that, it gives me how many oxygen? 3. Okay, I only have 1 here, so what goes here? Okay, how many sodium does that give me? 6. What needs to go here? Does that fix the phosphorus? It does. Okay, now there's 2 on each side. Okay, is that making some sense? Okay. Like I said, like sometimes people get really intimidated by like, oh my gosh, I don't know what the products are. But Dalton made sure, right? You can only have the stuff you started with. As long as you know the patterns of the 5 reactions, it's just a matter of putting the stuff you started with in a new order. Okay, because that's all that can ever happen in a reaction is I rearrange, separate, or join the things I started with. Okay, Let's try a couple more here and see how we do. So in number 6, I have magnesium by itself, so element reacting with lithium nitride ionic compound. What kind of reaction are we looking at? Single replacement. Okay. In a single replacement reaction, the pattern is that the element swaps out the part of the ionic compound it's like. Magnesium is a metal, so who's going to wind up alone? Lithium. All right, lithium's alone. Magnesium is going to be with nitrogen, according to the pattern. All right, is lithium a special element? No, but I still have to check, right? Got to make sure it's not a special element, so I don't need to put any numbers next to it. This is what kind of compound though? It's ionic. All right, so +2, -3, I've got to drop and swap. So Mg3N2. Okay, now that I've dropped and swapped that, now I can balance. Biggest number is 3. It's on both the metals, but magnesium has a bigger charge. Okay, so I can put a 3 here. That'll balance the magnesiums. Then I can look at the nitrogens. There's 2 over there, but only 1 here. So now my nitrogens are balanced, and that gives me how many lithium? 6. Then I'm all done. Okay? So if you're starting to get annoyed by me asking like the same question every single time I start one of those things, just know that's what you need to do in your head. Okay? Ask yourself those questions. What kind of reaction is this? What's the pattern for this reaction? Okay, I'm going to do that every time because that's just part of good teaching. Okay, but like for you guys, if you get past the point where you need to do that, that's fine. Okay, but that's the steps. What's the reaction type? What's the pattern? Use the pattern to make the new matches. Balance the reaction. Okay, you're always going to do the same things, right? Check for special elements. Swap and drop ionic compounds. All of those things are part of the process. Okay, number 7. What kind of reaction starts with only one reactant? Okay, in a decomposition reaction, what are those going to do? They're going to separate. Does it matter which one I write first? No. All right, what do I need to check about them? Are they special? Are both of them special? Okay, how special is phosphorus? Okay, how special is chlorine? Okay, now we got a balance here. So 4 is the biggest number. Put a 2 here to balance the phosphorus. Gives me 6 chlorines. 3 times 2 is 6. Should be good to go from there. Okay. Hopefully it feels like when you didn't have the products, like all you're doing is just basically once you have the products, it's all the same after that. All right, last couple here. Let's see how we do on these. Okay, last 3. It's not a couple, it's 3. What kind of reaction do we have in number 8? It's a combustion reaction. What are always the products? Carbon dioxide and water. Okay, do I need both rules for this one? No, 7's an odd number. Okay, so alphabetically going with carbon. 7 carbon, 16 hydrogen, 8 times 2 is 16. Okay, and then the oxygens. 7 times 2 oxygens is 14. Plus 8 times 1, so another 8 more, right? That's going to give me 22. 11 times 2 is 22. Okay. The combustion ones, other than the balancing, are probably the easiest because you always know what the products are. It's always the same thing. Okay, how many people have done number 9? All right, this one can trick people sometimes. What kind of reaction is it? It's synthesis, yeah, it's 2 elements. They're going to form a single compound. What compound? NaCl. Why do I have to write it in this order and not this order?
Because
Metal always comes first in an ionic compound. Okay, that kind of thing comes up all the time and people just forget. Okay, it's not that they don't know that rule, but they just forget. And they go ClNa. Okay, because that was the order it was in over here. If I'm making an ionic compound, I'd better make sure I do it in the right order. Now, that is dropped and swapped correctly, so I'm good there. I've got 2 chlorines. Now the reaction is balanced. Okay. All right, how many people have done 10? We're getting this stuff. That's good. Okay. Right, so for number 10, I've got phosphorus as an element reacting with lead-2 chloride. What kind of reaction would that be? Yeah, single replacement. Okay, so in a single replacement reaction, this has to replace what? The chlorine, right? So chlorine's going to wind up alone. Lead is going to wind up with phosphorus. Now, here's a situation we haven't encountered yet. Lead has more than one possible charge. Will it have the same charge in the products as it had here in this compound? Yeah, the charge isn't going to change in the reaction. Here it was lead-2, so here it's also lead-2. All right, so when we drop and swap, Pb3, P2 for that. Okay, what about chlorine? Am I missing anything there? It's special, comes as a 2. Okay, and then 4 is our biggest number, so let's try and make that work. Put a 2 here. That gives me 6 leads, so I got to put a 6 there. That gives me 12 of those, so a 6 there will fix that, and then it should be good. All right, the only thing that makes this just a hair trickier is if I give them to you like number 11. Now I give you only the reactants, and they're in words. So now you have to write the reactants out in formula form and then predict. Is there a little bit more detail that has to be managed with that? That's as tricky as they get, okay, is to go to that step. All right, since we still got 4 minutes, try 11. See how you do with that. By the way, we did amazing today. I never had any dream we were going to get that far. Just in case you want to check here. That's how that one should go. Okay, for tomorrow, okay, you got your quiz tomorrow. Do you try the practice quizzes? You can do everything that's on those now. Okay, if you normally write in learning support, please just come in, put your phone in the pockets, check in with me, and then you can go straight there and get started writing your quiz if that applies to you. If it doesn't, come in, put your phone in the pocket, and sit down and get started on class. Okay, all right, great work today, guys.